Welcome to Talk Tensors. You know we love to dive deep into cutting-edge machine learning papers, and today we've got a fascinating one. GeoPixel. Pixel grounding large multimodal model in remote sensing.
It's a mouthful, right?
Haha, yeah. But the paper itself is really exciting because it tackles a tough challenge, bridging that gap between language and high-resolution remote sensing data.
Like satellite imagery.
Exactly. Imagine an AI,
Yep.
right? That not only sees objects in a satellite image, but can describe them to you, like in detail, and pinpoint their location down to the pixel.
Wow. Okay, that's impressive. So, like, it can say there's a car parked in front of a specific house.
Yeah. And outline the car and the house perfectly, pixel by pixel.
So to get how groundbreaking this is, we kind of need to look back at how large multimodal models, LMMs, have worked with remote sensing, over time.
Yeah, good point. So where do we start with that?
Well, for a long time, those models had trouble with the unique challenges of aerial imagery.
What do you mean challenges?
Well, think about it. Everything's from a top-down perspective, right? And the objects vary wildly in size, plus high-res images have so much detail.
Yeah, I see. It's not just recognizing a car. It's understanding that tiny car within the whole context of the image, right?
Exactly. Early LMMs weren't really up to that task.
So what did they do?
They often use bounding boxes to find objects, which is basically just drawing a rectangle around something.
Oh, okay.
But that's super imprecise and computationally expensive, especially with complex shapes or when things are really close together.
Right. I can see how a box around like a winding river wouldn't be very helpful.
Yeah. And that's where GeoPixel comes in. It's designed to overcome those limitations.
Being more precise.
Yeah, by using something called pixel-level grounding, so it outlines objects perfectly, no matter how complex the shape is.
That's incredible. So how does it actually do that?
The secret sauce is in its architecture. It has 5 main components.
5. Okay, break it down for me.
So first up is the adaptive image divider.
Okay.
It splits the image into chunks, so the model can process those massive high-res images efficiently.
Makes sense. Kind of like a divide and conquer approach, right?
Exactly. Then we've got the vision encoder. It's this powerful model, scaled CLAP VIT L14.
Catchy name.
I know, right? It analyzes each of those image chunks, extracting the visual features.
Yeah, like the colors, textures, and shapes.
Yep. And then those features get passed to a large language model, specifically intern LM27B.
Okay, hold on. Why a language model? We're talking about images here.
Because that's how it connects vision to language. This LLM has been trained on tons of text and code, so it can understand the meaning of those visual features.
I get it. So it's like translating the image into something the LLM can actually work with.
Exactly. And now, here comes the really cool part. The grounding vision encoder, which uses a frozen SAM2 encoder, along with the pixel decoder, take those visual features and the LLM's understanding and they generate these things called segmentation masks. Imagine outlining each object in the image, like in a coloring book.
Oh. So that's how it gets the pixel perfect outlines.
Exactly. That's how it differentiates between objects, even when they're really close together or have complex shapes.
Wow, so it's not just seeing what's there, it's understanding the relationships between the objects too, right?
Right. But to reach that level of understanding, you need a special data set, which is where GeoPixel D comes in.
A data set specifically for this. Okay, what's so special about it?
Well, it's designed to teach LMMs about those tricky high-res aerial images.
So it's like the textbook for GeoPixel.
Exactly. And it provides 3 levels of description for each image.
Oh, wow, 3 levels.
Yeah. It starts with a holistic scene representation, like a broad overview.
So this is a city with lots of buildings.
Yeah. Then it goes to individual instance observation, where it describes prominent objects and links them to their pixel masks.
So for our car example, it'd be like a blue car is parked in front of a 2-story house, and it shows the outlines of the car and house.
Right. You got it. And the 3rd level focuses on those densely populated areas, like clusters of cars or forests.
Okay, so it's not just saying forest. It's explaining how those trees are arranged within the forest.
Exactly. It gives the model a much deeper understanding of the scene.
That's super cool. But creating a data set that detailed must have been a huge effort.
It was. But they used this clever, semi-automated process that leverages other state-of-the-art LMMs.
So they used AI to help build the data set that would train this even more advanced AI.
It's like AI apprenticeship, and it clearly paid off.
Yeah, I bet. So how did GeoPixel actually perform when they put it to the test?
Well, let's just say the results were impressive.
Okay, I'm ready to hear all about it.
So one of the key things they looked at was how the size of those image chunks, the ones the adaptive image divider creates,
Mm.
how those affected GeoPixel's performance.
So, like, did looking at smaller pieces help it understand the bigger picture better?
Exactly. And what they found was that as they increased the number of those patches, so dividing the image into smaller and smaller pieces,
Yeah.
the performance kept getting better. It could identify and segment objects more accurately, and the descriptions got more detailed.
That makes sense, like zooming in on a painting to see all the little details.
Precisely. But of course, there's a trade-off. Higher resolution means more computational power.
The classic balance between accuracy and efficiency.
And that's another place where GeoPixel shines. Even when it's trained on super high-res images, it can still maintain good performance at lower resolutions during inference.
So it can adapt. That's great.
Yeah. Now remember those masks we talked about? The instance masks for individual objects and the semantic masks for broader categories?
Yeah, like a single tree versus a whole forest.
They wanted to see how GeoPixel handled those different levels of detail.
I'm guessing it needs both.
You're right. It actually performs best with a mix of both types of annotations.
Makes sense. Sometimes you need the wide-angle view, and sometimes you need to zoom in.
Great analogy. But there was one area where it really struggled. Those densely populated scenes.
Lots of objects packed together.
Yep. It had trouble deciding whether to create individual masks or one big semantic mask for a group of objects.
So like a parking lot full of cars, that'd be tough.
Exactly. And that highlights how important it is to train models on complex data.
Right. The more challenging the training, the better it can handle real-world situations.
And that's what they did. They created two sets of training data, one simpler and one more complex.
So testing if GeoPixel learns better from a basic textbook or a more advanced one.
And guess what? The one trained on the complex data did way better.
No surprise there. I guess that's like an athlete training with heavier weights, right? It makes them stronger.
Exactly. Now, there's one last bit I want to mention about the vision projection layer, that bridge between the images and the language model.
Uh-huh.
They experimented with freezing and training that layer during fine-tuning.
So basically, should GeoPixel stick to its pre-trained understanding of visuals or adapt based on this new dataset?
Precisely. And training that layer actually led to better performance.
So it's like giving the model a translator who keeps getting better.
Yeah. But even with all these amazing results, GeoPixel still has limitations.
Nothing's perfect, right? What kind of limitations?
Well, it still struggles with those densely packed areas.
A parking lot problem.
Yeah. Sometimes it makes fragmented or overlapping masks, which obviously isn't ideal.
Right. It's like our brains. Sometimes it's hard to tell where one object ends and another begins.
Exactly. It just shows how complex visual perception really is.
But that's what makes this research so exciting. Pushing those boundaries of what's possible.
Absolutely. And they have some ideas for future work, like more robust masking strategies.
Makes sense. But overall, GeoPixels has made incredible progress.
Right. It's like we've opened this new door to understanding the world, not just with our eyes, but with the power of AI.
And not just for remote sensing either, right? These insights could be used in so many fields.
Absolutely. From medical imaging to robotics, the possibilities are endless.
It's really exciting. But speaking of exciting, you mentioned some novel notions you wanted to explore.
Oh, yeah. Let's get into those, shall we?
Definitely. Let's push those boundaries even further and see where GeoPixel could lead us.
Remember we talked about GeoPixel time? That idea of analyzing image sequences and tracking changes over time?
Yeah, like flipping through a photo album of the Earth.
Well, imagine combining that with other data, like weather patterns or climate models.
So not just seeing the changes, but understanding why they're happening.
Exactly.
Now that would be incredible, a truly dynamic model of our planet.
We could analyze the impact of drought, track urban development, or even model the effects of climate change.
Wow. That'd be like having a crystal ball for the future of the Earth.
Precisely. And that's just one idea. There's so much more we could explore with this technology.
Okay, well, I am definitely on board for that exploration. But for now, I think we've given our listeners a lot to chew on.
Definitely. And as always, we encourage everyone to dive into the paper themselves.
Absolutely. And until next time, keep those brains buzzing.
See you then. Welcome back to Talk Tensors. We're deep diving into GeoPixel, this model that's really pushing the limits of what we can do in remote sensing, especially with understanding and describing those high-resolution images.
It's like GeoPixel is giving those images a voice almost, letting them tell us their stories in a way that we haven't seen before. But I'm curious, how well does this thing actually perform? Can you talk a bit more about its capabilities?
Oh, absolutely. One of the best things about GeoPixel is its ability to handle images that have really, really high resolutions. Remember when we talked about the adaptive image divider earlier?
Yeah.
Well, the researchers actually did experiments to see how the size of those image chunks, those local and global views, affected how well GeoPixel performed.
So they were testing if looking at smaller pieces of the image helped it get a clearer picture overall, kind of.
Exactly. And they found that when they increased the number of what they called inference patches, meaning they were, dividing the image up into smaller and smaller chunks, the model got better and better at doing its job. Like it was
Yeah.
able to identify and segment objects more accurately, and even the descriptions it generated became way more detailed and, interesting.
That makes sense, right? The more detailed the analysis is, the more details it can pick up on. It's like if you're looking at a painting up close versus from far away,
Yeah.
you notice way more when you can see every brushstroke.
Precisely. But there is, of course, like a little bit of a trade-off here. While higher resolution means better performance, it also needs a lot more computational power. Processing those tiny details takes time and resources.
So it's that classic dilemma in machine learning, right? Accuracy versus efficiency.
Hmm.
Always seems like there's a balancing act.
You got it. And this is where GeoPixel's design really shines. Even when they train it at a super high resolution, it can still keep up a pretty decent performance level at lower resolutions during what we call inference. It's like GeoPixel can adjust how much detail it focuses on depending on how much computational power it has to work with, which makes it way more adaptable for real world situations where, you might not have unlimited resources.
That's a great feature. It means that, you could use GeoPixel even for tasks that need results quickly without having to give up too much accuracy. That's
Yeah.
really useful.
Absolutely. Now let's circle back to those masks we talked about. You remember how GeoPixel can generate both instance masks, outlining individual objects, and semantic masks, representing bigger categories, right?
Yeah, right. So like an instance mask would show you the outline of a single tree, while a semantic mask might show you like the whole forest.
Exactly. And the researchers really wanted to dig into how GeoPixel handles those different levels of detail. Like, did it prefer working with the precise outlines of each object or, the broader strokes of those semantic categories? What do you think?
I mean, my guess is that it probably needs a bit of both, right?
You got it. GeoPixel actually does its best work when it was a mix of both types of annotations to work with. This suggests that the model is really benefiting from being able to adjust how much detail it uses, depending on the specific scene and what objects are in it.
So it's kind of like having different lenses on a camera. Sometimes you want that wide angle lens to see everything, and sometimes you need that macro lens to zoom in on the tiniest details.
That's a perfect analogy. But there was one scenario where GeoPixel had a bit of a tough time, and it was when it had to deal with these mixed annotations in areas where there were a ton of objects packed together.
Oh, I see. So like a really crowded parking lot or a busy street, something like that.
Exactly. Images with lots of things close together, those really push the model's segmentation abilities to the max.
Yeah, I can imagine that being super hard, like trying to untangle a bowl of spaghetti.
Uh-huh, yeah. And that's a good reminder of how much data complexity matters in machine learning. The more varied and challenging the data you use to train a model, the better it'll be at handling situations it's never seen before.
So it's not just about having a lot of data, but also making sure the data is high quality and covers lots of different scenarios. Like giving a student a tougher course load, they might struggle more at first, but ultimately they learn a lot more and develop better skills, right?
That's exactly it. And the researchers actually went ahead and created two sets of training data for GeoPixel. One set had simpler annotations, like where every instance of a class was treated the same way, and the other set had more complex annotations, where some objects were individually masked while others were grouped together.
Okay, so basically they wanted to see if GeoPixel learned better from a simple textbook or a more advanced one.
Precisely. And the results were super interesting. The model that trained on the more complex data showed a huge improvement in how well it performed. It could segment things more accurately, and its textual descriptions were way more detailed and informative.
Well, that's a perfect example of how pushing a model with more complex data gets you better results.
Mm,
It's like giving an athlete a tougher workout. They might hit their limit, but it makes them stronger in the end.
totally. Now, there's one more technical thing I want to bring up. Remember that vision projection layer we talked about before? The part that translates the visual features into something the language model can understand?
Yeah, like the bridge between images and language.
Exactly. The researchers did some tests where they both froze and trained that layer during fine-tuning. Freezing means they kept those parameters the same, while training means they let the model adjust them based on the GeoPixel D dataset.
So they were basically testing if it was better for GeoPixel to stick to what it already knew about visual information, or if it should try to adapt based on this new data it was getting from GeoPixel D, right?
You got it. And what they found was that training that vision projection layer led to better performance on certain metrics. So fine-tuning this part of the model seems to help GeoPixel get even better at that back and forth between the language of images and the language of words.
So it's like giving the model an even better translator, one who keeps improving their skills and getting more adept at capturing all the nuances of both visual and linguistic information. Pretty cool.
Very cool. But even with all those achievements and these really insightful experiments, GeoPixel isn't perfect. It's still got limitations, like any model does.
Yeah, that's true. Nothing is perfect. What kind of limitations did it run into?
Well, remember how we talked about those densely populated areas that were tricky for it?
Oh yeah, the parking lot problem.
Yeah, well, GeoPixel still struggles with those sometimes. It has trouble deciding if it should create individual masks for every object or just use a single semantic mask for the whole group.
It's like our own brains sometimes, right? It's hard to tell where one thing stops and another starts when they're all crammed together.
Exactly. It just shows how complex visual perception really is, both for us humans and for machines trying to learn it.
But that's what makes this research so cool, right?
Yeah.
Trying to push past those boundaries and figure out what's possible.
Absolutely. And the researchers have laid out some interesting directions for future research, like maybe exploring how to use more robust masking strategies or even dynamic resolution adjustments. But even with the limitations it has now, GeoPixel has really made some incredible strides in bridging that gap between language and high-resolution remote sensing.
It's like we've opened this whole new way of understanding the world, not just with our eyes, but with the power of AI too.
And it's not just about improving remote sensing either. What we learn from this can be applied to so many areas, from medical imaging to robotics to even, self-driving cars.
It's true, the possibilities seem endless.
Yeah.
But you mentioned earlier that you had some novel notions you wanted to explore. You ready to dive into those?
Oh yeah, let's push those boundaries even further and imagine what we could do with GeoPixel in the future. You remember when we talked about GeoPixel time? That hypothetical model that could take image sequences and analyze them to see how things change over time?
Yeah, like flipping through a photo album of the Earth.
Yeah.
Watching cities grow and forests shrink.
Exactly. But imagine if we took that even further. What if we could combine that ability to understand how things change over time with other kinds of data, like weather patterns or even climate models?
Oh, wow. So we could have a model that not only sees how the world is changing, but actually understands why those changes are happening.
That's the idea.
That would be incredible. A
Yeah.
truly dynamic model of our planet.
We could use it to analyze how things like droughts are affecting agriculture, see how urban development is impacting biodiversity, or even model the complex interactions between climate change, migration patterns, and how we use our resources.
It'd be like having a crystal ball that shows us the future of the Earth. We could see the potential consequences of our actions and make better decisions about how to protect our planet. Welcome back to Talk Tensors. It's amazing how this deep dive into GeoPixel has taken us beyond just the technical stuff,
Yeah. We're talking about the big picture now, how AI is changing our understanding of intelligence itself.
Right. In the last parts, we were blown away by GeoPixel, how it analyzes images, creates those precise outlines, and even sees changes over time.
Yeah, it's a lot.
But now I'm thinking, what does all this tell us about AI in general? Like, what's its impact going to be on society?
Well, one thing that stands out about GeoPixel is how it understands what it sees, linking language to those complex images.
With a whole different kind of intelligence, right?
Yeah.
Not just what we usually think of as human intelligence.
Exactly. GeoPixel is all about visual perception, spatial awareness, extracting meaning from all that visual data.
So it's showing us there are many ways to know the world, different types of intelligence that can work together.
And that opens up so many possibilities for collaboration between humans and AI. Imagine scientists, urban planners, whoever, working side by side with a GeoPixel-like AI.
Yeah, exploring different scenarios, making better decisions based on what the AI can show them.
It's not about AI replacing human experts. It's about AI making them even better.
I like that, a partnership.
Yeah.
But of course, with any powerful technology, there are ethical things to consider, right?
Absolutely. As AI gets more advanced, we have to make sure it's developed and used responsibly.
Like, what about data privacy? Could something like GeoPixel be misused for surveillance?
That's a valid concern. We need to make sure these tools are used for good, to benefit humanity, not for harm.
So it's an ongoing conversation we need to have, researchers, policymakers, everyone, really.
Right, it's a shared responsibility. But hey, you know what? Let's shift gears a bit and go back to those novel notions we were brainstorming.
Oh, yeah. Time to get creative again.
You remember GeoPixel time? That idea of analyzing images over time to see changes?
Yeah, like watching the Earth evolve, it was fascinating.
Okay, but imagine taking it even further. What if we combine that temporal understanding with other data, like weather patterns, climate models, even things like socioeconomic indicators?
Whoa, so we could see not only how the world is changing, but also start to understand the forces behind those changes.
Exactly.
That's a powerful idea. We could analyze the impact of climate change on different regions, track how diseases spread, see the long-term consequences of how we're using the land.
It'd be like having this incredible model of the Earth, showing us the interconnectedness of everything.
It could help us make better decisions for the future, for the planet.
And that's what's so exciting about this field. It's rapidly evolving, and we're just scratching the surface of what's possible.
It feels like we're at the edge of something huge, doesn't it?
It does. GeoPixel is leading the way, showing us how AI can perceive and understand the world in ways we never thought possible.
And it's up to us to make sure those advancements are used wisely to create a better future for everyone.
Couldn't have said it better myself.
Well, that wraps up another deep dive here on Talk Tensors. I want to thank you for taking this journey with us, exploring the fascinating world of GeoPixel and what it means for the future of AI.
It's been a pleasure.
As always, we encourage everyone to check out the paper themselves and keep those brains buzzing. Until next time, keep exploring, keep questioning, and never stop imagining the possibilities out there.
See you next time.